Hi everyone. Before we learn about the generation of an action potential, we are going to look at these three important terms: membrane potential, resting potential, and action potential. What is membrane potential? Membrane potential is the difference in electrical charge across a cell's plasma membrane. This happens because of the unequal distribution of ions inside and outside the cell. Now, let's look at resting potential. Resting potential is the electrical potential difference that exists across the plasma membrane of an excitable cell under resting potential. What does resting mean? It means the axon is not transmitting any impulses. Why is it resting? Because there is no stimulus. During the resting state, the membrane potential inside of the axon is more negative compared to the outside. The value of the resting potential is -70 millivolts. How is the resting potential maintained? First, there is an unequal distribution of ions between the extracellular fluid and the cytosol. The axon membrane has more potassium ion channels than sodium ion channels, which makes the axon membrane more permeable to potassium ions. As a result, more potassium ions diffuse out of the axon than sodium ions diffuse into it. Second, the sodium-potassium pump plays an important role. It pumps 3 sodium ions out of the axon and 2 potassium ions in, helping to maintain the resting potential. Third, both the voltage-gated sodium channels and potassium channels are closed, preventing any ions from passing through. Lastly, inability of large anion to leave the cell because the plasma membrane is impermeable to chloride ions. If a stimulus is present, it causes depolarization. If the depolarization reaches the threshold level, it will trigger the generation of an action potential. What is an action potential? An action potential is an electrical signal that travels along the membrane of a neuron, allowing communication within the nervous system. During an action potential, the membrane potential inside the axon becomes more positive, as sodium ions diffuse into the axon. This graph shows the changes in membrane potential in the nervous system. 1. Resting potential. The membrane potential starts at the resting state, typically around -70 millivolts. 2. Depolarization. When a stimulus is present, it causes depolarization, which means the membrane potential becomes more positive as sodium ions diffuse into the axon. 3. Rising phase of action potential. If the depolarization reaches the threshold level, it will trigger the generation of an action potential. This is the rising phase, where the membrane potential becomes more positive due to the influx of sodium ions. 4. Falling phase of action potential. After the peak of depolarization, the falling phase occurs. This is where potassium ions diffuse out of the axon, and the membrane potential starts to become negative again. 5. Undershoot. Finally, there's an undershoot, or hyperpolarization, where the membrane potential briefly becomes more negative than the resting potential before returning to normal.